Hello everyone, Deepan from Team QLite here to demonstrate project predict carbon dioxide emission from cars using Azure Machine Learning linear regression algorithm built for Hacktech 2023. Let's see our project how it helps in real time. One of the major problem for the global warming is CO2 emission from cars, which leads to sea level rise and frequent weather changes, climatic changes happening due to CO2 emission. Also, it affects human health, causing respiratory and cardiovascular diseases. Our solution outcome is to predict CO2 emission from cars using machine learning algorithm. Some of the use cases in which have overcome by building and training a model using and analyzing data from the past 2022. Why Azure? Azure is one of the best CSP provider in current world, which is highly scalable and available. Our machine learning algorithm components are listed here. Have a view. The source image is extracted from the Azure official website, which shows some example and clear view how Azure machine learning works. This is our machine learning model which we have built in order to evaluate and train which results CO2 emission for the 2022 and predict for the future years and to control it. This is a user story how a car buyer and as an individual helps to stop CO2 emission and to build a sustainable environment world. Let's see our user story in real time. This is Azure dashboard. Requirement for Azure machine learning is we need to have Azure dashboard with subscription and machine learning service. This is the machine learning workspace environment. In machine learning workspace environment, we have created a designer in which abstract all the data using a valid dataset which has been captured from a Kaggle website for the 2022. And using the dataset, we are going to train and analyze the model. First, the data is captured from local file in from my mission. Instead of that, we can have it captured through the SQL database for real-time live analysis, or from other Azure storages like Cosmos DB or any other blob container services, online services as well. And we are kicking the endpoint in which the input and analyze data to be stored as Azure Blob Storage, which will be comes from the Azure Workspace, machine learning workspace. And I'm going to capture the workspace from my local mission, the CO2 emission data, which you have extracted from the Kaggle 2022 website. And here we are going to delimit the semicolon from the CSV file, and we are going to have the schema as string type, and we are going to create it. And next we are going to create a pipeline for our job run flow. In designer we are going to select our data file, and next we are going to have to split the data for to analyze the output and it transfer to the other dataset to train. And here we are going to use the linear regression algorithm to train the model. We have given model training in which the split data and linear regression model data is captured and passed through the trained model. Once the trained model is in progress, it will check for the column name CO2 emission is the unique one which we are going to analyze and get the result for future prediction. And here we are going to have the evaluation criteria to be set for to check the data part according to the car model and the fuel type, the vehicle type, weight, kg, and the fuel consumption details. Once the model is created in designer mode, we are going to have the compute target. Compute target is an instant cluster in which the model is going to run. The how much capability we are going to give, that much time consumption will be reduced. Here we are going to have some 6 cores model which is cheaper one to train and provide result output. It will take some time more because we are going for just a standard one. If you go for more core CPU, the time consumption will be less, and then result will be outcome will be in a quick timely manner. and the result of the score model is visualized in a graphical format. On the last two column, CO2 emission and the score level is listed, which will be with the predicted CO2 emission. Let's see in our model the clear view of score model. This shows the car type and the fuel type and CO2 emission and the score label. So in this way we can analyze the score type of the model and which one will be best and suitable, we can go for it to provide a sustainable world to control from the carbon emission. Thank you for giving the opportunity to learn and explore new things. All the details are captured and listed in the GitHub repository. The links will be provided in PDF format. Also, you can go and check this link for the Swagger details, and you can check our live project in this endpoint by having a valid subscription and Azure ML resource. Thank you.